Okay, so I'm going to do an example from the homework talking about the central limit theorem. The hint is they'll say find the probability of the mean or the average. And then you have to make sure either the original data is normally distributed or your sample size is more than 30. You already given them the distribution, the mean, the standard deviation, and sample size, and are randomly selected. And then what you're going to use is you use a normal CDF key. This is the mean of the x-bars, which is the same as the mean of the original data. The standard deviation of the x-bars is sigma over square root of n. So this is the part you have to remember. So these two main things, okay? So let's take a look at this one. I'm just going to do the B part because that's the only one that relates to the central limit theorem. The A part is just like the earlier sections here. Okay, so let's just kind of read over here. So up here it says the mean weight of candies is 0.8542. So I wrote that right here. Standard deviation is 0.0511. And then down here it says if 440 candies are randomly selected, find the probability that they're mean. Okay, right there's the hint. That's when you use the central limit theorem. That their mean weight is 0.8536. Okay, so I have to find the mean of the x-bars, which is the same as the mean of the original data. And I have to find the standard deviation of the x-bars, which is sigma over square root of n. And that's where this part right here comes into place. So that's sigma over the square root of 440. Okay, so right here in the middle is my mean, and we're looking for 0.8536 or greater. So we're looking for this area right here. So this is my low value. My high value, I want to put a bunch of 9s because it's technically infinity. And I'll put this mean and then this standard deviation. Okay, let me show you in the calculator. And it's a little bit different. The answers I get in my MATLAB, it could be off just a tad, like we'll see that right here, because sometimes you use a table for the answers, sometimes you use a calculator, but both answers will be acceptable. So I'll talk about that in a minute. So let me show you how to plug this in the calculator. Oops, I'm sorry. Plug this in the calculator, especially this last part. So I'm going to go to normal CDF. My low is 0.8536. The high is infinity, so we just put a big number in there. The mean is 0.8542. Okay, and then this is part that's tricky. The standard deviation, I'm just going to go ahead and plug this in. So again, I'm just going to go ahead and plug 0.0511 divided by the square root of 440. I'll just plug it right in there. That way I don't have to worry about rounding. Because you really don't want to round to the very end. Okay. So I'm going to go ahead and enter. Now, with the older calculators, you may have to put parentheses on this whole, like you may have to put parentheses here. I think in the older calculators, I automatically put a parenthesis here. You have to close it and then maybe close it again for the whole thing. I'm going to show you what I mean. So make sure however many parentheses you have on the left, you have as many on the right. So again, the older calculators, this is a newer calculator, you may have to have a parenthesis here, so then you have to have another one here. So just kind of keep that in mind. You'll be able to tell because you'll get an error of some sort. Okay, so this is my answer. I get 0.5973. My MATLAB lists the answer is 0.5987. They're off just a little bit, but my MATLAB accepts both of them. This is if you do it by calculator. This is probably if you do it by the table, but my MATLAB accepts them both.